Okay, I'm going to work through the Chapter 9 test review, the first 29 problems. Then I'll move to the angle of elevation worksheet. I've also been emailed about some questions on 9.3 practice A. So I will walk through that as well. Some of these are like 9.3 practice A. So maybe that will help. I'll just point out the ones that are like that as I'm going through them. When I get down to there, they're a little bit further down on this worksheet. For questions 1 and 2, we're to use the diagram below to give the exact trigonometric ratios. So the first one we're asked to find tan theta. Well, tangent is opposite over adjacent, opposite over adjacent. And in this particular problem, we're actually given opposite over adjacent. We're given the measures of the side. So that's going to be 24 over 7. So that's going to be B. The second one, we're asked for secant, and secant is the inverse of cosine. So cosine is that's going to be adjacent over hypotenuse. So the inverse of that is hypotenuse over adjacent. We don't have the hypotenuse here. So we need to find that by doing 7 squared plus 24 squared equals 49 plus 576. And 576 plus 49 is 625. And the square root of 625 is 25. So we're going to have opposite. We're going to have it's 25. We're going to have the hypotenuse over adjacent, which is 7. So that also is B. If sine theta is 8 over 9, what is cotangent? And cotangent is the inverse of tangent. And as we said earlier, tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. And sine is opposite over hypotenuse. So this is opposite, and this is hypotenuse. So you're going to have 8 squared plus b squared equals 9 squared. So that's going to be 64 plus b squared equals 81. And then 81 minus 64 is 17. So b, the square root of 17, can't be reduced any more than just to say the square root of 17. So if we're putting in adjacent over opposite, want to draw your little triangle, which I'm looking for room. Here, let me erase this. It helps to draw the triangle. Nice triangle. Oh, somebody's with me. I can hear you very little.
Hey, Miss Sparks.
Who joined me?
Ellie.
Hello.
Oh, Ellie. And Alex is here. And Garrett is here. Oh, praise the Lord. I love it when I'm not alone. Yay. That makes me so happy.
Good.
I just think I'm just sitting here talking by myself. It makes it feel so much better when somebody's here. Ellie and Alex and Garrett.
Hey, Allie.
That
Hi.
was Momo.
Hi, Mo.
And she said hi to everybody else. Aren't y'all glad school's almost over? Yes, praise the Lord.
Praise the
So
Lord.
opposite, and then this is going to be the adjacent will be 17. So if I'm taking the adjacent and sticking it over opposite, it's going to look like that. So that's going to be D. Y'all probably knew that before I did. I have to draw the triangle. I need a word picture.
I have a question.
Yes.
I was gonna say what we did.
Oh, hold on just one second. I'll ask. So much going on. Oh, yes. And let me apologize also, guys, for being late. I was at the doctor's office and traffic was horrible getting home. I was freaking out.
Oh, you're
But I
good.
was trying to get to you all. I was trying. I really was. If tan theta is the square root of 7 over 5, then find cosecant. What we know is cosecant is the inverse of sine. So sine is opposite over adjacent. So this is going to be no, it isn't. It's opposite over hypotenuse. So this is going to be hypotenuse over opposite. And tangent is opposite over adjacent. So I'm going to draw. I have to have my little word picture of triangle. I'm really sorry. I don't know. Can y'all do it without the word picture? Is it just me?
I can do it in my head a little bit.
Can you really? Oh, Ellie. What about you, Garrett? Are you a word picture person?
I always try to draw it, but I don't have to have it.
Y'all are so smart. I'm so proud of y'all. That's amazing. Okay. So, adjacent, opposite. And so now we need hypotenuse. So 5 squared. I guess this one I might have been able to do if I really would have gone ahead and written my numbers down. Oh, Lord, please help Miss Sparks. 32 equals C squared. All right, so we get to factor because that's going to be under the radical. I really could have just seen that as 4 squared, really. So that's going to be C is going to be 4 times root 2. So that means we've got hypotenuse, which is going to be root, this one right here. Yay.
What was C? What was C
No,
again?
I lied. I lied. Did I lie? Did I factor too much? What did I do? I did something wrong. I feel like I did something wrong.
I think you're on the right track because if you do 4 root 2 and then it's hypotenuse over opposite, so 4 root 2 over root 7, and then you just multiply both the top and the bottom by root 7.
Got you.
And then you'll
Thank
get A.
God you were here, Alex. Okay. I have Momo asking me questions at the same time, so I'm a little shook. I'm sorry. 4 root 2 over root 7. I'm in math lab. No. It's Garrett and Ellie and Alex. Alexandra. Yes, you do know Ellie.
Who's talking? I can't hear.
There we go. Praise the Lord. Thank God Alex helped me. Thanks, Alex. Shout out to you.
You're welcome.
Thanks, everybody, for helping Miss Sparks with math today.
What do we get on number 1?
We got that. We got B.
Okay, thank you.
Do you see why, baby? Oh, when did you join us?
I joined like 2 minutes ago.
Cousin Brady.
Oh, okay. Well, welcome.
Thank you.
Oh, it's a math lab party. I love that. That makes me so happy.
I did have a question, Miss Sparks.
Yes, love.
So was this angle of elevation and depression trig worksheet? Do we have to complete that, or was that
1, 3, and 5, and it was to help you because you're going to have an angle of elevation question on the test tomorrow.
and that has to be turned in with all the other sheets?
It wasn't on the
I mean, you don't really have to turn that particular one in. I don't know. Did I have the review worksheet on the assignment thing? The one I'm mostly worried about is the one that I'm working on right now. But
Okay.
my suggestion is that you at least try some of those angle of elevation so you know what you're doing tomorrow on the test.
Okay.
Hey, Ms. Sparks, can you scroll back?
Yes,
up
love.
can you scroll back up to 4 so I can fill it in? Rest of
Absolutely. Can you read that writing, Garrett?
it? Not really.
Are you just getting used to math lab writing?
It's nothing. I can't really get used to it.
If there's something I need to decipher of my chicken scratch for you, please let me know.
What was C?
I'm sorry?
What did C end up being?
It ended up being, it is 4 root 2. So I did factor correctly. So it's 4 root 2. And then cosecant is hypotenuse is over opposite, which is 4 root 2 over root 7. So I had to rationalize my denominator by multiplying. That's the part that Alex helped me with. So I had to multiply root 7 over root 7. And so then I ended up with 4 root 14 over 7.
Okay, that makes lots of sense. Thanks.
Okay. Yeah, no problem. All right. So we're supposed to find x to the nearest 10th. And I need to find my calculator. There it is. Because you have to have your calculator for these because we're getting into some cosine and sine where you're actually using your calculator. So what the sides that we have an adjacent side measure, and we have a hypotenuse. So that would be where we're going to use cosine. So cosine 33
I missed part.
equals, yes, x
So
over
my
6.
calculator will not turn on.
Are you having a bread calculator too?
Do you mind if I use yours during the test tomorrow?
No, but that's what happened to mine. Have you charged it recently?
I don't have a charger for it. It's an old one.
Oh, yes, you can use mine tomorrow, sweetheart.
Okay, thank you so much.
Do we need to have a funeral for yours like we had one for mine?
I think we do.
Mine too.
Oh, did yours die too, Ellie?
It did. I dropped it.
Oh,
More like a murder.
my God. Oh, I am so sad for both of you. What are we going to do?
I'm gonna
Thank
take
you.
someone's.
Funeral. That'll be
Funeral.
good.
A multi-funeral in Algebra 2 class. All
I
right.
think so.
People dropping those all the time.
I'm
It's like-
sorry.
I see people dropping their calculators almost every day at school.
I've broken two
Oh.
since I came to Cornerstone.
Ellie.
Luckily, one was the cheap one, so Christine wasn't mad at me, but the second one she wasn't nearly as happy about.
Oh, baby girl.
It's okay.
I'm so sorry.
It's good.
Oh, I don't like it when Christine's mad at you, honey.
Well, she wasn't mad for long because she broke her phone the same week, and so she's like, you know what? I was the one that messed up more.
Oh, well, yeah. Oh, but that's a hard hit for the Janzik family that week. That was a tough week.
Calculator cases.
Yeah, that I have. You're not even going to believe this, Garrett. I have a calculator case.
No, you
And
don't.
my last one broke in the case.
I'm kind of shocked.
What?
But I need to get like, I don't know, like a Tonka level case for it, maybe. Tonka's built tough. Find x to the nearest tenth. All right, so the side links that I have are my adjacent side and my opposite side. So that we know we're going to be working with tangent. So tan 76. You kind of got to figure out what side you got first and then go from there. And so you're going to, tangent is opposite over adjacent. So that means we're going to have 21x. Remember, the shortcut when you have your variable in the denominator is just to flip places with your tangent 76 and your x. I proved it in class and I've proved it once on Math Lab. I hope y'all just trust me at this point. And let's just do this and work this out. So now all you have to do is type into your calculator if you had one that worked. If you don't, if you have an iPhone, you can turn it sideways and it's got tangent and cosine and all that stuff on there. I don't know if it has inverse though, but you can at least do, and yeah, I think 21. Yeah, actually you do need 21 divided by tan 76. And you get 5.2. Yes.
Can we use our phones for the test tomorrow?
No, baby. But nice try, love.
Yeah, it was worth a shot.
Yeah, I know. I like how you slid that in there. That was pretty slick.
You know I had to. Miss Brooke.
I know. All right, so now we're going to find an angle. So this is where we're going to have to use that handy dandy little inverse thingamabobby. So we've got the side measures that we have are opposite over hypotenuse. Opposite over hypotenuse. So that's sine theta. So that's going to be sine theta equals 26 over 32. So we're going to take the inverse of both sides, and that ends up looking like this. So we've got second inverse sine 26 divided by 32 equals. So our angle measure for theta is 54.3. For number 8, find the measure of theta to the nearest tenth. So what we have is the adjacent side and the hypotenuse. So adjacent and hypotenuse. That's cosine. So cosine theta equals 11 over 11.8. So theta equals inverse cosine 11 divided by 11.8. Second cosine 11 divided by 11.8. 21.2. Any questions so far? Do y'all feel pretty good about this so far?
Yeah.
Okay, good.
That's
Great.
kind of random in Sparks, but I wasn't early enough to see the first 2 problems. Could you quickly scroll up to those so I could copy those down?
Sure. Brayden, did you get them? Did he leave me?
I don't know, maybe.
I hear.
Okay.
I'm sorry, I didn't hear what you said.
I said, did you get number 1 and 2? Because Garrett asked me to scroll up and get those real quick. And I just wanted to make sure you got them.
Yes,
I
I
got
I know.
did.
Okay. All right.
Thank you.
Uh-huh. Are you good, Garrett?
Yep.
All right. Convert 63 degrees to radians. So whenever you're converting, this will help with chemistry too. You want what you're trying to get rid of in the denominator of your ratio that you use. So we're going to want degrees down here and pi up here because we're converting to radians. And so I know 9 goes into both of them. What else goes into both of them? 8. Does 18 go into both of them?
I don't know. I'll look.
Nope.
18 can go into both of them. 63 and 180, right?
No.
No,
No, I
so
think it's
far
just
I think
9.
the only thing I'm finding is 9.
Because
Yeah, I think-
63 divided by 9 is 7. And that's a
Yeah.
pi number.
Oh, yes, there you go. Good thing Alex is here to keep us all straight. We'll just keep on trying stuff. So 9 goes into both of them. So 7 pi over 20. All right. Convert negative 280 to radians. I always want to make sure, just to remind you guys, when you're converting a negative number, don't forget your negative in your answer, okay? So we've got negative 280 degrees. So once again, what you're trying to get rid of, you want that in your denominator. And so 20 goes into both of those. So it's going to give me negative 14 up here and 9 down here. So that's going to be negative 14 pi over 9. Now, convert 13 pi over 18 radians to degrees.
Yay.
So we want to get rid of radians. So we want the radian or the pi measure in the denominator, so they'll go away. And 18 goes into itself 1 time. It goes into 180 10 times, and 10 times 13 is 130. So the answer is 130 degrees. Convert 19 pi over 10 to degrees. And once again, we want to get rid of that pi measurement, so it goes in our denominator. 10 goes into itself 1 time. It goes into 180 18 times. And 18 times 19 is 342 degrees.
Yep.
Okay.
Could you swap to 9 and 10, Sparks?
Yes. The terminal side of an angle measuring 13 pi over 12 radians lies in which quadrant? Okay, now what I have to do is draw my, oops, wrong thing. I have to draw my quadrant. And I know, but my unit circle's kind of circling around that. But I know over here is pi. So see my denominator right there? I know that if I were going to make this pi, that would be 12 pi over 12 would be 180, because I know that this is pi over here. 180 and pi are the same thing, because remember, we've been doing 180 over pi and pi over 180 to convert. So what I would want to do is, oops, I did that. Please. So I want to convert this to something where I can make a comparison of 13 pi over 12 to 12 pi over 12, because I know that 12 pi over 12 is the equivalent of pi. Does that make sense to everybody before I move on?
I don't quite know. Like, this is the part that I've struggled with the most. I was going on homework 3 today, and I like don't get any of this.
Okay. All right. So if I'm looking, I'm gonna borrow number 14 for just a minute, just the space. This does not have anything to do with 14, okay?
Got it.
When you're drawing your unit circle, this is 0 over here, and this is pi over here when you're measuring in radians. Does that make sense to you?
Kind of. I don't even quite get like what the radian is. Like, this is the part that I have not gotten to click.
Okay. All right. Fair enough. And this is a very difficult like transition to make. So I completely understand that.
Mm-hmm.
Let me see if this analogy helps a little bit. And if it doesn't, just let me know.
Okay.
You know how here in America, we're used to kind of measuring feet in inches. That's just what we're used to. So if somebody says, oh, that's, a foot long, like a foot long sub, all of that other stuff. We're kind of used to that. And so we don't really think twice about that measurement.
Yeah.
So when I say degrees to you, you don't think that much about degrees, because you're like, okay, I can accept that. That goes into my brain. Okay, I may not completely get that, but I know there's 360 degrees in a full circle. I know there's 180 degrees in a straight line. I know there's 90 degrees in a right angle. Those things, you're comfortable with.
Yes.
Well, all radians is it is the metric system of degrees.
Okay, that helps a little bit.
Okay, so it's like pi radians is the exact same things as 180 degrees.
What do you mean?
So, I'm sorry?
Like, is that like why 2 pi r is in the formula, like for the circle thing?
Yes.
Okay.
Yes,
So,
because 2 pi is the radian measure of, and it's actually more precise even. It's the radian measure of that. That's it exactly. That's totally it.
So 1 pi is 180.
Yes, it's a straight line. And 2 pi is a full circle.
Got it. But how does that connect to the quadrants and like how I know which terminals work in which? And I know it has something to do with like clockwise versus counterclockwise with the negatives and positives. I don't know.
Yes, you're absolutely onto something. Remember, the unit circle is just the coordinate plane. That first unit's kind of blown up.
Yeah.
Okay. But you're actually making measurements based on a circle, which is probably why I drew the circle first.
Yes.
But these can, just like any old pie, any old circle, cake, whatever, bagel, donut, whatever you're thinking of, can always be broken down into however many. If there's 12 people splitting up, and I'm going to get to the quadrant in just a minute, but like there's 12 people splitting this piece of cake here.
Okay.
So that's why 12 pi over 12 is because we're going to break this thing down into 12 pieces. So that's the fraction part. The
So the
quadrant part,
So
the
wait,
quadrant part is this. Because it's the coordinate plane, it's the unit, the very first block of the coordinate plane blown up.
the quadrant.
Big. Yes. Yes. So like if I were to get a blank graph, just a regular blank graph where we're used to drawing lines and parabolas and all of that stuff, it's the origin. This right here is the origin
Okay.
of the coordinate plane.
Okay.
So if I go one right here, I've gone 1 unit right and no units up. So that's why the coordinate is that,
Okay.
1, 0. And if I go 1 unit up, I've got 1 or 0, 1, because I haven't gone left or right any. That's where the quadrants come in. It connects to the coordinate plane.
Okay.
And then the pi measurement is the radians. And then when you get various denominators, you want to think of it breaking that pi into that number of pieces.
Uh-huh.
Okay. So I've got in this half of the pie right here,
Yeah.
I need to cut that into 12 pieces, right? But I'm going to go a little itty bitty bit past that because it's 13 pi over 12. So I'm going to go over to here just a little bit. So it's going to be in quadrant 3.
Okay, so can I work that out? I flipped it back into degrees and then put it on the unit circle. Does that work? So like
It does.
I multiplied the 13, like just like in the formula before, and put it back into the degrees that I can understand and then base it from there.
Sure.
Okay.
If you wanted to do that, you definitely could do that.
So like just to make sure that it works, negative 324 would be how it flipped into the next one. And on the unit circle, negative 324, that would be back in quadrant 4, right?
For this next one, for number 14?
Yeah.
Well, you're going negative. So on this one, I've got, this would be 5 pi over 5 to get me to here. Because remember, you're going clockwise now, not counterclockwise.
Mm-hmm.
So I'm going 4
around, so it'd be
this would be 7.5, and then I would have to go a little bit more, so I'm going to be over here. So if you were doing 324 in degrees, you would have gone, actually it would be a little bit more than that.
So it's A.
Yes.
Quadrant. And do you start at 0 and you count from there, kind of, right?
Yes.
Okay, that clicked. I understand.
Okay. All right. But don't forget, this right here determines which direction you start in.
The negative or positive, or the 12?
Yes, ma'am. The negative.
So
if I'm going in a positive direction, let me change colors. If I'm going in a positive direction, I go this way.
I'm sorry, where? I see the new color. Okay. So you start at which quadrant?
I start at quadrant 1 and move 2, 3, 4. If I go in a negative direction, I start at like the X near quadrant 1 and 4, but I go to 4, 3, 2, like that. That's my directional, because the negative tells me I'm going in a clockwise direction and the positive tells me I'm going in a counterclockwise direction.
Okay.
So the answer for this is A, and the answer for that is C. Does that help?
A lot.
How about anybody else?
Yeah, for sure.
Okay.
And then like even just like, I don't know, the coterminals and the reference angles, I have no idea what's going on there.
Okay. It's very similar.
Okay.
Very similar. So we're looking, The coterminal ones are a little easier. And I'm going to remind you guys of the calculator cheat again when it's radians, because I know no one likes fractions quite as much as Mrs. Sparks, and I get that.
Very true.
But with coterminal angles, what you're going to do is just add that 360 or subtract the 360, depending upon whether if it's asking for you for a positive coterminal angle, obviously you want your answer to be positive. So you're going to add or subtract multiples of 360 till you get the desired answers. In this, we only have to go up one. You're going to get 488, which is D. If it was asking me for a negative one, I would have subtracted 360.
And
Does that make sense?
But then how do you know when it's not multiple choice if you have the desire? So like to get a negative coterminal, if I wanted my answer to be negative, I would have subtracted 360.
Yes, ma'am. So what happens if I subtract 360 from 128? What happens?
You don't get one of the answers on the board thing.
Yeah. But if you're right, though, if it's not multiple guess, which tomorrow's isn't, negative 232 would be coterminal.
So how do I choose which one how do I choose whether it should be a negative or positive coterminal?
Well, if it's asking give a positive and a negative coterminal, then your answer that's positive is the positive coterminal, and your answer that's negative is your negative coterminal. And you're going to look at your original number and figure out how much you have to add or subtract in multiples of 360. So it would either have to be 360 or 720 or something like that. Does that make sense?
Yeah, so if I was at like a positive 500 and I needed a negative coterminal, I'd subtract 2 sets of 360, right?
Yes.
Got it.
Yeah.
That makes sense.
Yeah. Great clarification questions.
Thank you. That's perfect.
Okay. Now, which angle is coterminal to 2 pi over 5? Now, basically, what I would want to add is 2 pi to this, okay? Because 2 pi is equivalent to 360, and to get a coterminal angle. So what I told Braden to do the other day, when we did a few of these together, we did open parentheses, 2 divided by 5, close parentheses, plus 2, math, enter, enter.
I was trying to do that on my phone calculator, and then I got Luke's calculator, which like wasn't a scientific one, and I cannot figure out how to get that. I was like always getting some weird answer, and they were getting some weird answer.
Well, when I did that on here, I got 12 over 5, and that's not one of my options. So what I'm going to do now is go 2, open parentheses, 2 divided by 5, close parentheses, minus 2, math, enter, enter. On his, I can't remember what the fraction button is, but you would still do the open parentheses, and then whatever your fraction is, close parentheses, plus or minus 2. There is a fraction button. I really want to say it says F to D. It's like second and then F to D, and it's like second from the top if it's the one I'm thinking of.
Yeah.
And that gives me negative 8 pi over 5. So my answer is C. So exactly what you're typing into your calculator looks like this.
Where are you writing? Where are you writing it?
Can you not see it?
I just saw it. Sorry, I wasn't watching it move, and then it moved.
Okay. 2, you would put open parentheses, 2 divided by 5, close parentheses. And here I'm writing plus or minus because it would depend upon what you're trying to do. You know what I'm saying? If you're trying to go up, you would add 2. Obviously, if you're trying to go down, you would subtract 2. And then you hit math, enter, enter. Okay?
But didn't it not give you the right answer?
Well, the first time it was the correct answer. It was 12 over 5. It just wasn't one of the options.
So then how did you choose 8 over 5?
Because it probably making this multiple choice actually made it harder for you guys.
Okay.
The 12 over 5 is a positive coterminal angle. The negative 8 over 5 is a negative coterminal angle. But both are correct answers. They're both coterminal.
Oh, so you didn't do the minus version.
I did the minus version for this, but I entered the positive one first. Does that make sense?
Kind of. I'll go back and watch more videos, and if it doesn't click again, then we'll figure it out from there.
Okay. Well, I don't want to move on until you get it. Okay. So when you're looking for coterminal angles, and it's in radians.
So is there a way that I can just flip it to degrees and then convert it back?
I mean, you could, but then that math shortcut isn't going to work.
I don't mind doing it by hand. Like, that doesn't throw me off at all.
Okay.
So
All right.
if
I mean, because basically on this, you're going to still, over here
Mhm.
where you had to add and subtract 360 for a positive and negative coterminal angle,
Yeah.
you're doing the exact same thing over here. You're either going to add 2 or subtract 2. I added 2, and the answer gave me 12 pi over 5, which is absolutely correct if I was looking for a positive coterminal angle. But it was not one of my options. So I said, oh, okay, well then I'll subtract, and I did, and I got a negative coterminal angle, which was negative 8 pi over 5.
I just don't understand, like, how by subtracting 2 from that, how come it's not 0 pi over 5? Why is it 8 pi over 5? Negative 8 pi over 5.
Okay, good question. All right, because remember, this 2 is 2 over 1. Okay, so let me show you what that looks like. If I am adding 2 over 1 to 2 pi over 5, then I have to get the same denominator for both. 1 goes into 5 times, and 5 times 2 is 10. So this is the equivalent fraction to 2, so 12 pi over 5. If I were subtracting, if I were subtracting 10 pi over 5, which is the equivalent, the equivalent is 10 pi over 5, then I would get negative 8 pi over 5. So when you're subtracting 2, you're subtracting 2 wholes, like 2 whole pieces of things. And this is 2 pi over 5. So you have to have a common denominator. This is how I originally did it in class, and no one liked it because you had to get a common denominator. But maybe you'll understand it better getting a common.
Yeah. I got
Does that help? Does that help you?
That works in my head, yeah.
Okay. So that's what you're doing. In order to subtract fractions, you have to have a common denominator.
Got it.
Okay. Cool. All right. Number 17. The reference angle for 205. Okay, a reference angle is always an acute angle. So it's 90 degrees or less. So what we're going to do is look for the angle 205. Well, we already know this is 180. So 205 is going to be just a wee bit past that, right?
Yes.
So it's going to be right in here. Roughly. So what that means is I am looking for the shortest distance back to the, like if I went all the way over to here, that would definitely be over 90 degrees, wouldn't it?
Yeah.
So I'm looking for that shortest distance back to an x-axis. So it's going to be this right here, that little green arrow measure. And that green arrow measure is 205 minus 180. It's always in a positive acute angle is the reference angle. Always positive, always acute.
Okay.
the reference angle is. So my answer is 25. Or D, or what is that, B? B.
So you just subtract or add 180 to the reference angle?
Well, you have to figure out where it is, because like if that angle's all the way over here, then it would be to here.
So
You have to figure out where it is. And then you're looking for the shortest distance back to the x-axis.
which is
so
always that 180 line.
Yes. Yeah. But it could be, it depends upon what quadrant you're in. Yes.
So why isn't it 15?
Did I subtract wrong?
No, you did. You did not. Oh, I understand. So you took the 205 and you subtracted 180 from it, and that's how you find the.
Yes.
So like, if it was 100, if it was just 200 flat, and it would be 20, right?
Correct.
And if it were 300, it would be 120. Well, that doesn't make sense. Not acute.
It's not acute. So if it were 300, it would be 60. Because if you were 300, you'd be over here in this quadrant,
You'd be using 360.
all the way over here. So you would want to then go to this one, because that's the shortest distance back to the x-axis.
So you use 360.
So you would do 360 minus 300, which would be 60.
So on the right side, you use 360, and on the left side, you use 180.
Mm-hmm.
Got it.
Yes.
Okay.
And then if your angle's up here,
Yeah.
if my angle was up here somewhere, I would still use 180, but this would be the reference.
So it might be okay.
So, let's say it's 110.
30.
180 minus 110, the reference angle would be 70. The shortest distance positive to the x-axis.
Got it.
Acute, positive.
Okay, got it.
Okay. All right, the reference angle. So for me, I can still, I'm weird and I've grasped radians, but this right here in this measurement would be 10 pi over 10. This pi would be. So I haven't quite made it to the 180 mark or the pi mark. It's going to be somewhere over in here. It's going to be 3 pi tenths back. That way, which means my reference angle is going to be 3 pi tenths.
But how do you know off the top of your head that because you want to make it back to the 10?
I want to make it to 10 over 10. Yeah, because 10 pi over 10 is really just pi because the 10s cancel. So the shortest distance back to the x-axis.
Okay.
Or, you can do pi.
So like what would
No, go ahead.
Sorry, I'm trying to find an example that I can ask from. Let me find homework 3. I have it in the stack somewhere here. You can keep going.
Okay. The terminal side of a theta position, and I believe someone emailed me about this, so I really want to focus on this for just a minute. So the terminal side of theta in standard position contains the point -4, -2. Find the exact value for each trigonometric function. All right. Now with something like this is a what you like on the ACT or SAT or that kind of thing, or sometimes if you're looking up videos, if you need some further instruction or understanding of this is going to be a non-unit circle trigonometric function just using the coordinate plane.
Mm-hmm.
So what you're going to do on that is draw your lovely little coordinate plane. And this is just going to be a rough sketch, so please forgive me. And I'm going to go over 4 to the left. 1, 2, 3, 4. I'm faking it till I make it. And then down 2. Okay. So my little cute little point's going to be over here somewhere. All right.
Okay.
And so there's my wonderful little right angle. How cute. -4, negative 2. Did you find your question you wanted to ask with regard to the reference angle before I move on?
Yeah,
I'm
sure.
sorry?
Yeah. So like if I was on number 17 of homework 3, if you have it like right next to you, but if it was 5 pi over 18, would I want 13 to make like 13 to even it out?
Okay, you just said 5 pi over 18, if I'm not mistaken.
Yeah. So would I
Well,
want 13 over 18?
I'm really glad that you asked this question because if I do 13 pi, okay, the radian measure for 90-degree angle is pi over 2.
Mm-hmm.
So that means if I have something that's 9 pi over 18 or greater, it's not going to be a reference angle.
So
So literally, the reference angle for 5 pi over 18
mm-hmm.
should have been 5 pi over 18.
So I'm sorry, what is the thing that if it's greater than what, it's its own reference angle?
Well, you don't want, like we learned that it can't be 90 degrees, right? It has to be 90 degrees or less. The radian equivalent to 90 degrees or less is pi over 2. So when the denominator is 18, then my reference measurement needs to be less than 9 pi over 18. And you gave me a reference angle of 13 pi over 18, which is greater than 9 pi over 18. Because 9 pi over 18 reduces to pi over 2. So when it's a small angle like that, it's going to be its own reference angle. Was the answer 5 pi over 18?
I don't know. I haven't finished it yet.
Okay.
Or like the next one, 18 on that is negative 11 pi over 9. And it's asking me for a coterminal, which I could figure out, but then it's a reference angle. But is it just not available?
The 11 pi over 9.
But it's negative.
Yeah, a negative 11 pi. That just means that I'm going to go this direction.
Mm-hmm.
And then 9 pi over 9 would be right there, right?
Yeah.
And then I'm going to go a little bit further. So it's going to be here. So my reference angle is going to be 2 pi over 9.
Okay.
Because I went 2 pi past 9 pi over 2.
Okay.
Does that make sense?
A little bit. Yeah, I got it.
Okay. And if, like you said, if you want to convert to, degree measures, I guess you can if it helps you, but just don't forget to change it back because if you're asked in radians, it is expected that you will answer in radians.
Okay.
Okay.
I got it.
All right, back to this. Now I've drawn my cute little coordinate plane and kind of faked my points. The fact that I went, left 4 and down 2. All right. So that means I know that this is my X side. So that's negative 4. This is negative 2. And theta, by the way, is always, love you, be careful. Theta is always in the coordinate, the coordinate side, because this is your right angle, but theta is always, this is always here. Does that make sense to you guys? Okay. So I've got my adjacent side and I've got my opposite side, and that kind of always, so now what I'm going to do is find my hypotenuse by taking negative 4 squared plus 2, negative 2 squared equals my hypotenuse squared. So that's 16 plus 4 equals h squared. 20 equals h squared. So that's going to be, I'm just going to pull out square roots. This one's fairly easy. 2 root 5 equals h. So this is 2 root 5. So that means my adjacent side is -4. My opposite side is -2. And my hypotenuse is 2√5. So when I'm looking for sine, I'm looking for opposite over hypotenuse. So -2 over 2 times √5. So that's going to cancel to give me -1. But this, I have to rationalize my denominator. So that's √5 over 5. And that's actually negative because I've got this -1 right there. So it is D. Okay.
You don't have to read it, but do you have any, just like a 5 or something? Because I have to pay for the ticket.
I only have 20, but you can take it.
I'll look for one if there's not. I'll just show her. I'll get it. I don't want to take this one.
And then cotangent. Hold on just 1 second, please. Sorry, very sorry.
Okay, thank you so much. Love you.
I love you. All right, cotangent. Sorry. Cotangent is the opposite of tangent. Tangent is opposite over adjacent. So this is going to be adjacent over opposite. So adjacent is -4. Oh, praise God. And opposite is -2. That reduces to 2. Oh, that one was beautiful. Wasn't that beautiful?
I love that. I could do it myself without you doing that.
Yay!
Learn something.
Y'all are geniuses. Everybody's been helping me today. And I hope, does that make sense to you guys? Like when it is a non-unit circle trigonometric function and you're using coordinates, it's always a good idea to give yourself a little word picture.
Yes.
You
That makes
know,
a lot more sense.
Yeah.
Yeah, to try and figure out where it is and all of that stuff. And the terminal side just means, that's going to be, basically that's saying, okay, that's where my hypotenuse is going to be.
Yeah.
Okay, so hopefully that helps. So that's a non-unit circle trigonometric thingamabob. How about that for technical stuff? All right. So this is where this cotangent, Lord Jesus, please help Miss Sparks. Cotangent theta is less than 1. So we're looking for where cotangent is negative. Now I just want to add to you that cotangent is absolutely the inverse of tangent, but an inverse of something is not going to change whether it's negative or positive. So these are all the places that it is positive. Remember, all students take calculus. Or if that's doing it in the counterclockwise fashion, if you want to do it Miss Sparks' way and look at the clockwise fashion of it, it's acts, which is how we're supposed to pray with adoration, confession, thanksgiving, and supplication. So clockwise, it's prayer. Counterclockwise, it's all students take calculus. But what we're looking for is all the places where tangent is negative. So all of the trigonometric functions are positive in quadrant 1. Sine is positive in 1 and 2. So what we're looking at, we absolutely know that tangent isn't going to be negative in quadrant 1. So that's not going to work. In quadrant 2, its sine is positive. So that means tangent is negative. Tangent is positive in quadrant 3, and tangent is negative in quadrant 4.
So A.
So A is the answer because it is absolutely negative in quadrant 2 and quadrant 4.
Okay.
Does that make sense?
Yes.
It's a little harder when you're trying to look at the inverses, but basically if it's positive in 1 and 3, then it's going to be negative in 2 and 4.
Okay.
If sine theta equals cosine theta, in which quadrants could the terminal side of angle theta lie?
So is the terminal side the right or the left side? I was watching a video about it this morning.
The terminal side means where it's going to land, where the angle actually ends.
Okay.
And if sine equals cosine, the only place that that could possibly happen would be 1 and 3. Because they're both going to have to be, and that's going to be at a 45, 45, 90 degree angle. Does that make sense? Or not really?
No,
Okay.
I don't. How you know like what the angle is?
Okay. Remember in the sine theta and cosine theta and all that other good stuff, they're usually, when they're referring to when they don't give any special, quadrant measurements like -4, -2, like in 19 and 20, when you just see a pretty little sine this or these little things in the terminal side, they're asking you to kind of reference that unit circle. Okay.
Okay.
And so in order for sine and cosine to actually be equivalent, then you're going to be referring to that 45, 45, 90 degree angle, or those, remember when the coordinates are both √2 over 2, √2 over 2, and then over here, they're both negative on the unit circle. Remember that?
Yeah.
Yes, no?
Yes.
Okay, so that means it's going to be 1 and 3. Because up here, cosine and sine, one is positive, one is negative. And down here, one is positive, one is negative. The coordinates. There's in each quadrant, there's I know. Look. Over here. Can you see me?
I can.
Okay. All right. Right here, they're both the same exact. So this is cosine and this is sine.
Yes.
Remember, the x coordinate is cosine, the y coordinate is sine. They're both positive and they're both the same.
Right.
Here, they're both negative and they're both the same. But here, one is positive, one is negative. And here, one is positive and one is negative.
So
the only two places they could equal are here and here.
So it's where they're equal to one another?
Yes, that's what the question was referring to.
Okay.
If cosine theta is equal to if sine theta is equal to cosine theta.
Okay, I understand.
Yeah. And I'm going to honestly tell you, I personally think the test is easier. I think the multiple guess on this made it harder. Personally. Really? To me. to me, because I'm like, okay, when you don't have those options there and you're not trying to figure it out, you know, you're trying, when it's multiple guess, you're trying to narrow to something. So sometimes I think that makes it harder, but maybe that's just me. I'm not very good at multiple guess tests. I'd rather just try it on my own and get partial credit. So I'm one of those strange ones. Okay, so sine 120. Sine 120.
Yeah.
This is where hopefully you're going to fill that unit circle, the blank unit circle, out correctly tomorrow.
Yes.
And
So 25.
yes, so you can use your unit circle and you're going to look for sine 120. So here's 120 right there. And sine is the y coordinate. So it's root 3 over 2. Cosecant 225. So that's 1 over sine, because cosecant is the inverse of sine. So 225 is sine is negative root 2 over 2. I can say it. I promise I can. So it's if sine is negative root 2 over 2, then the inverse of that is 2 over root 2, or negative. And then I have to rationalize my denominator, right? So that gives me negative 2 root 2 over 2, and those cancel. So that's negative root 2.
Okay.
B.
And there can't be any negatives, or just to clarify it, like I'm pretty like there's no negatives or square roots in the denominator, right?
I mean, you know, I typically try to put my negative out to the side, like to the side of the entire fraction, indicating that the value of the number itself is negative. But there can't be any radicals in the denominator. You're absolutely correct.
Okay.
Okay, so tan 11 pi over 6. So that's going to be in my fourth quadrant, and it's tan. So that's y over x. So negative 1/2 over root 3 over 2. And remember, when you have a complex fraction with matching denominators, you can just focus on the numerators, because if you were to keep flip change, those denominators are going to cancel each other out.
Okay.
So now we've got negative root 3 over 3. Oops. So B. Secant pi over 2. And secant is 1 over cosine. So I'm going to look for pi over 2. And I'm looking for cosine, which is x, right?
Right.
So 1 over 0. Uh-oh, that's undefined.
Why is it undefined versus just 0? Okay.
Because you can't divide by 0. That makes math people shudder.
Okay.
1 over 0 is a no-no. Can't divide by 0.
Okay.
0 over 1 is acceptable. 1 over 0 is not.
Okay.
Can't divide by 0. Do you remember me wearing my T-shirt to class one day that says it was all fun and games until someone divided by 0?
Vaguely.
That is why.
Okay.
Just to remind you guys that you can't have a 0 in a denominator. Now, what function has a value of negative root 3? Now, what you're going to think about, once again, I think this makes it a little trickier because it's multiple guess. But what you're going to think about is that somewhere on here, you're looking for one of the trigonometric functions that has obviously a root 3 in it, right?
Yeah.
And so, because you're going to want to end up with that. You're also going to look in one of the quadrants where one is negative and one is positive. You know, your opposite, because it's y over x, right? Or tangent is, and all of my options are either y over x or x over y. So I'm either going to be looking at y over x or x over y, right?
Yeah.
And I'm going to want a negative. So I'm going to be looking in one of the 4 quadrants. I'm going to be focusing on one where one is positive and one is negative,
Uh-huh.
because a positive divided by a negative is going to return a negative.
Right.
So, and remember where I said when you're creating a complex fraction,
Mm-hmm.
that the denominators rule each other out when you create a complex fraction.
Yes.
So what you're going to want to do, some people are much quicker at this than even I am. So I'm going to kind of quickly peruse. I've got pi over 3 is not even going to work because they're both positive there. So I can kind of rule that one out, right? And then 7 pi over 6 is over here. So that actually is a possibility. And which one was it? Which trigonometric function was it? Okay, it's tan. So that's going to be y over like that. So that's not going to work because that's going to be 1 over root 3. We just did that a minute ago. So that one's not going to work. So we're going to look at cotangent 5 pi over 6.
Okay.
So let's see, 5 pi over 6. That's going to be, and we did cotangent. So that's going to be x. Is that right? X over y.
Mm-hmm.
So I'm going to focus, once again, complex fraction. All I really have to do is focus on that denominator.
Mm-hmm.
And that returns a negative root 3. So that's my answer.
Okay.
Once again, that's why I said this, because it asks the question in that way, you know, you kind of have to go through some of your answers like that. So in kind of the same thing, which one has a function, a value of 2? So you're going to kind of break through that and look for things that, you know, are going to return, you know, a value of 2. So that's going to probably be one of those where you have root 2 over 2.
Yeah.
Right? And so let's see. 11 pi over 6. Let's see where she is. One is positive and one is negative, and I'm looking for a positive result. So will that work? Which one is it? It's secant. So that's 1 over cosine. That's not really going to work because it's got root 3 over 2. So that one's not going to work. Right? Or cosecant, it's 1 over sine. Yeah. Oh, maybe it would. It's negative, so it won't work. So I'm going to go back and look at cosecant 7 pi over 6, which that's 1 over sine at 7 pi over 6. It's negative also, so it's not going to give me a positive 2. Good old 5 pi over 3. Where is she? 5 pi over 3 is down here, and it is secant, so that is 1 over cosine. So that's x. And so I take the inverse of 1/2, which is 2. So there I go. There's my answer.
Okay.
It's C. So you're just kind of using that unit circle to help you out. All right, which functions have a value of -1? So basically, you're going to be focusing on your quadrantal angles for the most part. So because that's going to be, it's a unit circle. So you're going to be looking for those places where everything is a 1, or where you're going to have these
Uh-huh.
angles, because that would also return a 1. So let's look at cosine pi. Cosine pi, which is over here, that's a -1. Am I looking for it? Oh, and so that works. Tangent 3 pi over 4. And that one would work too, because it's going to be root 2 over 2 over root 2 over 2, and it's negative. So that one works. Sine 3 pi over 2. That's going to be down here. Sine is the y value. So that one works. Cosecant pi over 2. So that's up here. And cosecant is 1. No, actually. Cosecant is 1 over sine, right? Is that right?
I have no idea.
Yes, 1 over
Okay.
sine. So that does not work. And then secant 3 pi over 2. Is 1 over cosine. So that one doesn't work either. Tangent pi over 2. That's y over 1. That doesn't work because that's undefined. Cotangent pi is y over 1, -1. It's 0. And then cotangent 7 pi over 4. That's all the way down here. And that one works. That's why I said sometimes with the multiple guess, everybody thinks they're going to be so much easier, and they're not always.
Yeah.
There was a lot, to me, there was a lot to that. But for me, it was also a very good review because you went through so many different types of problems, manipulating things.
So are we not going to have those like big charts where we have to fill out like sine, cosine, cotangent, secant, and the CSC on the test then? Or is it?
Doing all the figuring out all 6 of the trigonometric functions.
Yeah.
Those type. I don't know. There might be one on there because there were a few like that on here. I'm going to pull up the test on my other computer.
I mean like the giant ones because I didn't see any of those on the review. And I didn't know if it was just like assumed that we understood it perfectly.
I'm trying to think of what the giant ones look like.
Like the ones that are like a chart and there's 6 boxes and then they give you like a half finished triangle. And
like, did you have one on the take home quiz?
yes.
Yes, I think there is one on there.
Okay.
Hang on. Bear with me. I'm pulling it up. Yes.
Okay.
Yes, there is. There's 2 like that, the very first 2.
Okay.
But they are very similar to number 1 and 2 on this. You just didn't have to do all of them. But if you wanted to go back and do all of them, you definitely could. And then number 3 and number 4 are 2 more. We just didn't make you do all of them. But if you wanted to go back based on those units and just, finish them out, you could. But
Okay.
there's 2 like that.
Okay.
There's 2 like that. There's 2 like number 5 and 6. There's 2 like 7 and 8. There's 1 angle of elevation problem.
Like those are the word problems, right?
Yes, and we're getting ready to do one of those. And then there's 2 convert degrees to radians, just like 9 and 10. There's 2 convert radians to degrees, just like 11 and 12.
Okay.
There is 1 like number 19 and 20, this right here. There's one like that.
Okay.
But you have to find the 6 trigonometric functions. Here we only found 2.
Okay.
There is one like number 21 and 22. Only
Wait.
one.
Did you skip 15 through 18, or is there just nothing like them on there?
Hang on just one second.
Okay.
Oh, no, I did accidentally skip them, and I'm very sorry.
You're good.
There is one where you have to give a coterminal angle, both positive and negative, and it's in degrees, and one where you have to give a coterminal angle, both positive and negative, and it's in radians, and you do have to give the reference angle for both of those as well, much like the take-home quiz.
Okay.
I just didn't want to re-give you the take-home quiz as a study guide.
No, I understand. So it's are they like the ones on the homework where it's like they give you, like it kind of lumps it into 2 problems?
Yeah, like if you wanted to rework that, which I'm sure you don't, but anything that you struggled with on the take-home quiz,
Yeah.
if you fine-tune that and you could do the take-home quiz again, if you were given it, you'd be set. If you've done this and you could fix your take-home quiz, you'd be set.
Got it.
Then you have to find the exact trigonometric value. Did we do that? Please tell me we did. Yeah.
Yeah.
Then there's one like 23, 24, 25, and 26.
There's one like that.
Yeah, well, there's no, actually 6.
Okay. So
There's not anything like 27, 28, or 29. It's more like 23, 24, 25, 26, except there's 6 of them.
okay.
And then you will also be filling out a blank unit circle. But
Is that-
my suggestion is do that first and then use it.
throughout the test.
Yes, ma'am.
Is the,
Well, I'm sorry?
is the unit circle part of the weight of the test, or is it just there for reference?
It's part of the weight of the test,
Okay.
which really is almost a good thing because that's going to mean, in all honesty, there's like 60 questions then.
Oh, perfect. I can mess up.
So each one is going to be virtually worth 2.
Perfect.
Or we may not weight the unit circle quite that heavy, but it still helps in the quote unquote number of problems, if you know what I mean.
Oh, definitely. Yeah.
So did that help?
Perfectly. Yeah.
Yeah.
Okay. All right. And do you need me to review the unit circle with you?
No, I haven't. I just need to fine tune my memory of it.
Okay. All right. Any more questions on that part of the quiz, test, review, whatever this thing is?
No.
No, I'm
Okay.
good.
All right. I'm going to, and if you want me to go back over any of the homework problems, like there was one that's like, okay, like, because I know I got emailed about one like 19 and 20, and I know there were some like that. I believe it was on practice A 9.3. And if you guys need me to bring that up after we go over these angle of elevation problems, I will be more than happy to do another one.
My only question was, I don't remember if there was a math lab referencing homework 3. I just really want to make sure that I get that mastered because it's my biggest weakness.
And which one? The last one that we're given or the original?
The original homework 3.
Okay, I'm going to do a couple of these angle of the 1, 3, and 5 on this, and then I will go back to any homeworks that you want. Because in all honesty, I have one little errand to run after this, but I'm y'all's. I'll stay with you as long as y'all are working and you have questions. I'm here.
Thank you.
No problem.
I have
I
to-
want y'all to do well on this, and I want you to feel confident about it.
I need to get an A because I don't want to take your final.
Oh, bless your heart. Yes, I'm praying for everybody to get an A.
Well, thank you.
So and hopefully I've tried to go back through and reassign some of this because I want y'all to, when you go into whether that's, at Cornerstone or in college, I know trig is going to be a part of your next math class, and I want everyone to feel comfortable. And these are very foundational principles to moving on to higher level thinking in the trigonometric world. So I just want to make sure that we've got it mastered.
Thank you.
No problem. Okay, now
I
we're
have to
going to.
leave, Miss Sparks, but thank you.
Oh, no problem, sweetheart. Have a good evening.
You too.
Okay, Brian's flying a kite in a field at the end of a 65-meter string. See, there you go, meters. You know, it's kind of like radians. Help us, Lord. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head?
Okay. So the
All right.
picture.
So we're gonna do little Brian over here, and he's gonna be flying his kite, and he's got a 65-meter string.
So it's tangent of 70 times 65 equals x. No, I did it on the wrong leg. I put the thing on the wrong leg.
I'm thinking that's gonna be opposite,
Over hypotenuse.
is what I'm thinking.
So it's sine of
What
70.
do you, I mean, do you think so too? I mean,
Yes, I just put the string. Sometimes I get confused which long leg got to assign the thing to.
yes, you know what? I totally get where you're coming from on that. So we're gonna do oh, why did I even write 70 over there? Help. Miss Sparks. 70 degrees. Okay. And then we don't know what this is. Because I'm assuming his string is going to be the hypotenuse at an angle, right? Isn't that what you would think too? Because his kite
Yeah, that
way
makes sense.
up here in the air, right?
Yeah. That is sine times 65. Or sine of 70 times 65. Sine 70 times 65. Okay, I got 61.1.
You got it, girl. That's what I got too.
Perfect. Okay,
All
and then
right.
go on
All right. So we're going to go to 3. Because number 2 is the angle of depression, and it's going to be an angle of elevation. So from a point on the ground, 12 feet from the base of a flagpole, the angle of elevation to the top of the pole measures 53 degrees.
Okay, so
I'm assuming that this is the 12 foot, and I'm assuming this is 53. What do you think?
I agree with that.
Okay. And this is going to be how tall the flagpole is.
Yes.
Okay. So we've got adjacent over
Hypotenuse.
opposite. No.
Adjacent over hypotenuse.
No, yeah,
So
we don't want to do that to ourselves. We want to go opposite over adjacent. So we got tan
53
53.
times.
And that's going to be tan equals x over 12.
Yes.
Tan. $15.9. Is that what you got?
Yep.
We are rocking these. A man flies a kite and lets out 100 feet of string. The
So
angle of elevation of the string is 52 degrees. Surely
So,
we've got these down now.
yeah.
How high off the ground is the kite? How far away is the man from the spot directly under the kite? Eee.
Ooh, so are we using the ankles this time versus the legs?
Well, we've got 100 feet of string, so that's going to be, and our dude is over here, right?
The bottom of it, yeah.
And then this is our kite. So there's asking us 2 questions. So basically what we're going to do is we've got to find this one and this one. So
Oh.
we're going to use opposite over hypotenuse,
So sine.
which is sine, right?
Yep. Sine of 52.
52. And, oh yeah, I see what you're saying. We've got x over 100, right? So we got sine 100.
Wait, don't. Yes, yes. Okay. Sine 52 times 100.
Oops, I did it wrong.
Okay, I got 78.8 for that.
Okay. Me too. 78.8. So that means that the
And then we
height
can,
of the kite is 78.8.
and then can't we use Pythagorean theorem to find the rest?
Oh, we could.
So if the hypotenuse is 100, 78.8
We definitely could.
b squared.
I'm going to
equals-
see how close we get if I do the cosine thing, and you do it that way just because I'm a curious kind of cat.
Okay.
But they both should work.
1078.
You know what I'm saying?
Yes. 78.8 times 78.8 equals that. Yeah, 100 times 100 is that minus 20944. And then we're going to take the squared root. Crap. 3790.56. Okay, I got 61.6.
I did too.
Perfect.
Use cosine. We're so smart.
Brilliant.
I love that when a plan comes together.
I know.
That's awesome. All right. So anything else?
Nothing on that. Yeah, no. I was wondering if we could spend like 10 minutes on the initial homework 3. I crammed all of it and like learned all the skills during the take home quiz. And the one that didn't stick was homework 3.
Okay, let's look for it then. Let's do it.
But if you don't have time, I can watch your old math lab or something. Or
It's fine.
so I figured out. Sorry.
I'm fine with doing this.
I figured out the first 12 and then I checked them. And I'm good with those. I know how to work all the ratios. And then I started watching a video about like how to sketch an angle. And I kind of get that. And then everything from there just kind of goes downhill.
Okay. All right. So you want me to start with 13, kind of, sort of, is what we're saying.
Yes. So
Sort of. Okay. So, and you can see, I will have to erase some of this because I probably did some stuff already. So coterminal angles. So sketch an angle, give coterminals, one positive, one negative. So the coterminal angles are going to be where I'm going to add
yes.
115 plus 360. So that's going to be 475. And 115 minus 360 equals, I can't do that one in my head.
I'm going to pull up my calculator. 115 minus 360. Okay. Wait, crap. 115 minus 360. I got negative 245.
All right. Thank you. I was
So-
going to let you do that. I cheated and let you do it. Okay. So now I'm going to draw the angle. So I know, and it's positive. So I'm going to go to here. That gives me 90. And I'll go just a little bit past that because I know 115 is about 25 past that. You know, and I'm not great, at drawing these cute little angles, knowing exactly where they are
Just
or
do your-
anything like that. You know what I'm saying? But I'm going to say, it's about right there. Oops. I see. That'll tell you. I'm not great at that.
You're good.
So, and so then what I'm going to do is the quickest. So my co-terminals were what, 475 and negative 245. My reference angle is the quickest way to the x-axis, which is going to be this way,
So
right?
that's going to be
So
60.
that's going to be 180 minus 115.
So 65. I think I did it in my head.
You go, girl. You're a genius.
Oh, good it is.
There you go. There you go. Good job. Yes. So there you go. That's how you do that. And then the co-terminal angle here for the positive 350, I'm like, oh, girl, we are swinging around. We
I got
got
7.
to here and we didn't quite go all the way. So there you go. So
Yep.
then that reference angle, I'm sorry,
Okay, I was just agreeing. Sorry.
the reference angle goes to here. So your reference angle is 10 degrees. Your co-terminal angles, 350 plus 360
17
is 710
and then negative 10.
and then negative 10.
Okay. The next one, add 3.
So yeah, you want me to keep doing these, right? Oops.
Can I do the next one like quietly and then like check it with you just to make sure that I'm getting
Absolutely, because my eraser isn't working. There we go. I'm going to get my eraser working while you work away. How's that?
not perfect.
All right. Oh, there's where I was doing the math enter thing. I can see that.
So when it's a negative, is it just not available as a reference angle?
Oh, no, it is.
Okay. How much
We'll talk about it.
How much would it take to get back to 180?
The only big deal about being a negative on that is you're starting this way. Oops, helps if I hit the draw mark. I'm going this way. So I'm only going 40 degrees this way. So my reference angle, in all honesty, is 40 degrees. Really.
So it's just the opposite.
Yeah, because I'm going back the quickest way.
To the
That's my reference angle. So that's 40 degrees, but it's positive. A reference angle is always positive and acute.
Okay. So
I'm looking for the quickest way back to the x-axis.
got it. For my co-terminal,
I'm sorry. Go ahead.
Go
I
ahead.
apologize.
I was just saying
No, you're-
for the co-terminals, I got 320 and negative 400.
you are absolutely correct.
And then I don't think I sketched the angle right. I drew it just a little bit bigger than I wish I could like if I can how do I turn the camera on? To like
Oh, God. I don't have any idea.
Um,
Mine has a little button at the top. Up at the very top. Oh, there it is.
where is it? Here. I don't think I did it.
Oh, okay. Okay, you're right. You needed to go down.
So I did the right idea, just I went down.
Yes, you had the exact right idea, baby girl, but you went up in the counterclockwise direction. And when it's negative, you want to go clockwise.
Okay,
Okay? So that's the difference.
got
The
it.
negative means you're going to start and go down. But actually, you probably drew a more truer 40-degree angle than I did in the fourth quadrant. You just drew it in the first quadrant. And you want to go when it's negative, you're going to go down. Like given number 16,
Yeah.
you're actually going to go all the way around, hit your 360 once,
And then go up a little.
and then you're going to go 100 degrees more.
So around, so it would be up still. Because it's over 360, would I draw it upwards versus downwards?
Yeah.
Or
See what I'm saying? You're going to start down. Let me switch back to see what you're doing.
so like, that's the wrong one. That's it.
Yes, that's it.
Okay.
That's it. Because you circled all the way around. You snailed around that bad boy. And
Okay.
then, see, so we started here. Can you see mine? And you circled around. You hit that 360, but bam, then we go to 90 and then a little bit more.
Okay. And then for
So that's negative 460.
and then we would add so
The shortest distance back to here. So if I've gone,
and then the coterminals are 260 and then negative
good job. I'm going to show you how to use that 260 in just a minute.
and then negative 820.
Yeah, I'm going to show you how to use that in just a second. Okay, plus 360 equals negative 100. And then I just took the negative 100. I'm going to add another 360. Or you could take negative 460 and add 420 to it. Either way you want to do it. But this 260 right here,
Mm-hmm.
that 260, you could use one of these reference angles. That's why it's kind of important. Take that 260 and subtract 180 from it. Use that reference angle, subtract the 180, and you're going to get 80 degrees. And that's going to be this angle right here.
That's the reference angle.
Yep.
Is that always how it works?
Yeah, that's kind of why the coterminals work, because you can kind of take a look at it. You know what I'm saying?
Yeah, it works. Wait, like 320 or 360 minus 180. But then why it doesn't work for the one that we did before?
No, you're right. On that one, you would have to, because you're working with this side over here, you're going to do 360 minus 320.
Oh, and then it works. So that will work. That makes so much sense.
That's why the reference angles are the way they are.
That makes perfect sense.
Okay. Good job. And just look at the placement also. If I'm looking, this is about, basically 100. So, you're looking at 180, minus 100.
Yeah.
That's another way to kind of look at it, because they're all coterminals. That's the whole point of doing coterminals.
Okay, I understand that so much better.
Oh, praise God. You can see that I already did this. And this is the one where you said you preferred not working in radians and you wanted to switch it and then switch it back.
Yes.
Okay.
Since I haven't been using the normal calculator in like forever and a day, I've just like memorized either how to do it on my phone or in my head.
Okay.
Okay.
Because I was going to say with the coterminals on these, I mean, obviously you can switch it, just make sure you switch it back. Or, on this one, I would actually be adding 36 over 18 or subtracting 36 over 18 to get the coterminals. Does that make sense?
No, it doesn't click for some reason.
Okay. Because I'm adding 2 pi.
And then you have to multiply the numerator and the denominator by 2, right?
Just the numerator.
Right.
Because I'm getting a common denominator. The common denominator is 18.
So now
so now it's 36 over 18. That's the equivalent of 2.
and it's 15 pi over 36.
It's 41 pi over 18. Because when you add fractions, you don't add the bottom.
I have no idea where the 41 came from.
5 plus 36.
But how did you get the 36 if you multiply 5 times 2? Or
You're not multiplying 5 times 2. I'm converting 2 over 1 to an equivalent fraction with 18 as the denominator.
until you
So
multiply
1 goes into 18, 18 times, and 18 times 2 is 36. This 2 over 1, 36 over 18 is equivalent to 2 over 1.
I understand. Okay, so it's 41 pi over 18 is a coterminal.
Yes. And so if I was going to subtract to get the other coterminal angle,
Would you multiply the denominator by -2 and -1?
well, I'm just going to subtract 36. Once I've found my equivalent, my 2 pi equivalent, which is 36 over, I'm just going to subtract it this time, which is going to be -31 pi over 18. This is the equivalent of 2. So I'm just like you add 360 and subtract 360. Once I've got that 2 equivalent, I'm just going to either add it or subtract it. Remember, to get the, I'm sorry?
Yes, this makes a lot of sense. I clicked it. Yeah.
Oh, good, good. So I actually never used the 2 math enter. That's something I learned this year. I've always, and I think it's just because I understand fractions
I think
fairly. It just, fractions click okay with me. They've actually click better than decimals do.
really.
Except for when you're talking money. Money and percentages off when given a coupon. Mama can do those.
Okay. For the next
Those decimals I'm good with. But when it comes to this type of fraction, to me, I'm going to look at, I know I've got to add 2 and subtract 2. So I'm looking for the equivalent, which of 9, that's going to be 18 over 9. That's the equivalent of 2 expressed in a fraction with 9 as the denominator. So I'm going to add 18 over 9 to -11 over 9. So that's going to give me 7 pi over 9. So there's one of my coterminals.
And then -29 pi over 9.
Yes.
Okay, I understand the coterminals. That makes so much sense.
Good. It's really not that bad.
Really not.
Yeah. Okay, so now when we're looking at reference angles,
I just subtract 5. So, is it 36 pi over 18?
Well, what I would do is you still kind of have to get an idea of where it is. And number 1, it's negative. So I'm going to be traveling clockwise, not counterclockwise. So I'm going to be traveling in this direction. Okay. And so I'm looking for the reference angle, and I know that 9 pi over 9 is going to be over here because that's going to be pi. But I'm going to travel just a little bit past that. Actually, exactly 2 pi past that.
Okay.
So on this one, I don't know if you asked this question or not. Did you ask this? You would actually take the 7 pi over 9 and subtract 9 pi over 9 from it to get 2 pi over 9.
Okay. And is that the reference angle?
Mm-hmm. Because you're kind of looking for that small, you would use this coterminal angle because it's closest to 9 pi over 9. Do you see where I get the 9 pi over 9? Or not really?
You added 2 because you had to move 2 extra pi.
Yeah. Yeah, I added 2 because I moved, but the 9 pi over 9 is just because that is pi, just like 18 over 9 is 2 pi, 9 pi over 9 is just 1 pi. So that's my 180 side, and this is my 360 side.
Okay. Yeah, I don't know. The reference angles are definitely the concept that I grasp the least out of everything. Everything else makes a lot of sense.
Okay, good.
But I think I'll be
Yeah, I think you'll be okay.
okay.
It's just, remember, it's acute angle. It's an acute angle.
Okay. And then these ones are just using everything that I've been doing the whole time and converting it, right?
Yes.
Okay.
But you want to see how I drew my,
Your little thing.
I took that -5 and that 12 and I drew a little angle so that I could kind of figure out, okay, and your theta is always the one that's closest to the origin of that little coordinate plane. That's where your theta is always going to lie. Right here.
Yes.
And this part right here.
Yes.
And then you're just doing, once you get all your cute little things, like that first one's pretty easy, because you have normal numbers. There's no denominator to have to rationalize. The tricky part is when you get that denominator and you need to start rationalizing it. You know what I mean?
Yeah, and even that's not the end of the world.
No, that's not too bad either. You're actually, your math skills are on point. So you don't have to worry about that part. That's not, just, getting the newer concepts down. The trig part is the part that you need to maneuver through. But your math skills are always great on your tests. Always.
That's good to know moving forward and stuff.
Yes, they really are. I haven't done number 21 at all if we want to work through that one together.
That's perfect. I'm almost done with this last one. I'm just putting in the thingy. Opposite. Over.
On number 18 or which one, honey?
I was I was popping in the answers to 19. We can work 21 though.
Oh, okay. Well, that's okay. You just finished 19 and I'll do 21 and you can jot down the answers to 20 if you want to.
No, I'll work it for practice. I'll check it. There's homework to recheck, but thank you.
Okay. All right. No problem. All right. So I'm going over 3 and down 6. So over 3, down 6.
Make a little triangle. And then the theta is the one closest to a little thing that isn't the thing. And then
3, and then this is -6. And so we've got 3 squared plus -6 squared equals my hypotenuse squared. So 9 plus 36 equals h squared. 45 equals h squared. So it's going to be 3 root 5. So opposite equals 3, adjacent equals -6, and h equals 3 root 5. So opposite or sign is opposite over hypotenuse.
So -6 over 3 root 5, and then you have to rationalize that denominator. So that 5 comes out, and you have 15 over negative 6 root 5, and then that can reduce to negative 2 root 5 over 5.
Yep.
And then it's just 3 root 5 over negative 6 for the cosecant. And then for
Yes.
it's
But you can reduce. Did you get 3 root 5 over
it's-
negative 6? And then you reduce that to negative root 5 over 2. Yes. Good job. So cosine is,
wait, why is it a negative root 5?
well, it's negative root 5 over 2 because because it's negative 6 over here.
Okay.
You see that? This is negative right there.
Yes, but why did the numerator become negative and the denominator become positive?
Oh, it doesn't matter where you put it. One of them just needs to be it. Like I can literally just stick it out in front of the.
Okay, I'll just do that.
It doesn't matter. When you have a negative divided by a positive, something is negative somewhere.
Okay, got it.
Yeah. And so you could, if you put the negative next to the 2, I'd be fine with that. It doesn't matter, just so long as you know.
Got it. Negative 6 root 5 over 15.
Oops.
Negative 2 root 5 over 5. And then 3 root 5 over negative 6, 1, or root 5 over negative 2. Root 5, that's not what I got. That's
Did you
y.
get root 5 for secant?
For secant, I got root 5 over 2. I think, well, because cosine is adjacent, which is 6. Negative 6 over hypotenuse, which is.
No, cosine is 3.
I'm sorry, what?
Cosine is,
Oh, I was looking. I'm so sorry. I was off with the angle. That's not good. So I got the first one is root 5, right? Like
it's
just
root, it's
5
root 5 over 5 for cosine, and secant is root 5 all by itself.
got it.
Because okay.
That makes sense.
Okay.
And then tangent opposite, negative 6 over adjacent. So that's negative 2, and then negative 1/2.
Yes.
Perfect.
You did it.
That makes so much sense. Okay.
All right. Any other questions about homework or any of that other?
No, I think I got it. Thank you so much for the extra help.
No problem. Happy to do it. Email me if you need me.
Okay, thank you. Bye.
Bye-bye.